what you're talking about. It's maybe a design issue to be able to show what's happening, how it's going to happen, and I see as a no-brainer that people is going to go in
Yep.
my perspective.
Yep. And we just have to do a better job explaining it, like just super clear. And it's not there. It's not clear at all. So we'll do better. Um, any other thoughts on? I mean, we were talking last time about social entrepreneurs and the spiritually enlightened social entrepreneurs. Any more comments on that? Did you have any other thoughts to wrap up the discussion from like a couple of weeks ago, or?
As of now, not really.
Yeah.
I haven't think about maybe a strategy to be able to communicate better. You just mentioned that is a design issue, just to show them, and
Yeah.
maybe that's going to be the main turning point.
Mm-hmm. Yeah. So what do we want to do today?
I've been designing basically what I want to achieve.
Mm-hmm.
I want to do the cost structure of the irrigation systems, when component by component,
Mm-hmm.
identify what was behind the cost of each part of the total cost. And I believe that could give us a full clarity what's behind the cost and what can be optimized.
Mm-hmm.
One thing is the current design, but also the other very interesting part would be how to design these complete pots, that it's the pot, it's the growing media. I
Mm-hmm.
found extremely interesting, instead of using coco coir, be able to use the plastic filament plus the biochar.
Mm.
That would be a huge cost advantage, but most of all would be an integrated solution to be able to make the pot, the growing media, the recycling water loop
Mm-hmm.
into a single design.
Yeah.
So can I share with you?
Yeah.
Can we go into the slides
Yes,
just to
please.
see the full components that I was able to identify? And
Okay.
from there, I would like to get your help and your guidance into what would be important from now on to focus on.
Yep. Yep. Let's do it.
So I'll go into the slides.
Mm-hmm. Yeah, just paste the link into the chat box.
Yes, I see on slide number 4. I think.
Okay, 4. Mm-hmm.
Yeah, I'm on number 1. I just put a big note that highly interested in biochar and plastic filament instead of coco coir, just as a big note to put some focus into that. And as I mentioned, that the goal would be develop the pots into an integral solution
Yeah.
as a growing chamber, media, and water
Mm.
recycling. That would be like that finished product where, of course, that would be cost reduction, but there also would be the component of ongoing recycling. If we talk today about how a pot of hydroponics is made, we're talking about the plastic, could be the bag, could be the hard plastic pot. There are those two options. Then is the coco coir, or the different kind of growing media like perlite, and I forgot the other names. And there are also the drip lines. When you see those components, it's really hard to recycle, because how do you separate the growing media, such as the coco coir, to the bag or the hard plastic bag? If we're able to integrate into a single solution of making the pot with the plastic filament and biochar, that's a pure plastic recycling opportunity to be able to finish a cycle. We're talking 5 year to 7 year.
Ah,
Take the full pot and recycle it back. Since
wow.
it's full plastic and biochar as well, we're talking a single material component into an integrated solution. If we're
Mm.
able to make it happen.
How are you thinking that the roots will be separated out of that? Like dry out, or otherwise we have to figure out mechanical separation? Like I would see drying and then like, because there's gonna be biomass in there.
Yes,
mixed with the plastic. So how do you separate it? What are your any thoughts on that?
we're thinking about, as an example, the 7 year cycle and finishing the life of the plant, and then how do we recycle the part of the plant as well
So the roots are going to be all mixed in a growing medium. How do you separate that?
when we want to recycle the full pot we're
Yes.
talking. In my mind, doesn't the plant it's able to recycle because it's a natural component?
I would say decomposition. Yeah, you
Yes.
might have to ferment it out or whatever. Just decompose over time. Like leave them inert, or maybe like leave them in a moist environment where it just rots. It turns into it's like a throw them in a biodigester, you know, and the biomass just
Yes,
is turns into carbon dioxide and water.
correct. Since the pot will have some biochar and the plant is biomass, I would say the only added process would be maybe adding some microorganisms into the final cycle so we can decompose correctly.
Yeah, we can grow mushrooms from that and have a second crop.
Probably yes. My desire would be to make a life cycle design in order to make the full pot with the plant, decompose the plant components, and then recycle that into a material to make another pot.
Oh wow. And yeah, I mean the biomass, you know, it won't have that kind of the plastic long polymer chains like thermoplastic. The plant itself won't be thermoplastic, so it probably will be degrading the quality of the recyclability. But it could also be that that portion is so minor, it could be that it just, yeah, you just add 20%. Oh yeah, because in plastic recycling, they say that you have to add, like you can only recycle like 5 times, they say. And I can't vouch for that, but every time you recycle, the the polymer chains gets shorter.
Okay.
So typical, like Joshua Pierce, for example, he talks about that every time you recycle, you have either five tries, or you can add like 20% virgin material, but that's still 5x savings, right?
Very much.
So I mean, and we're starting with recycled anyway. So yeah, yeah, it's good, but that's just a consideration. Keep in mind. Um,
So one last comment about that, since the idea of the growing media would be biochar with plastic filament. The biochar, as I understand, it's basically you put any biomass that you can find. It can be food waste, it can be like parts of the tree. You treat it some way, and then it converts into that biochar.
Specifically, it's wood pyrolysis. Like you burn it. That's how you do it. So for example, here when we did the workshop, we actually ran a power cube on biochar, on char. We took wood, burned it incompletely, and it turns into carbon. So the hydrogen and oxygen comes off as gas, and you're left
Yes.
with just carbon. So that's the way. That's just one way to do it. Hmm.
Okay, so the decomposing part could be just waiting for the full decomposing and then take that residue
Yeah.
for me.
Well, so the chemistry there is, if you take that plant material, I mean, there's not a lot of it in there. So you need woody. Typically, people go from woody biomass, like trees, and they make charcoal. So it's like just like coal. Coal and charcoal are in principle the same thing. Carbon, just pure carbon.
Yes.
Yeah.
Okay.
Um, yeah.
That's a small detail. I mean, if we're able to make the integrated system, I think that the
I like
plant
it.
at the end of the cycle, we can even take it out with labor maybe, but that would be once in 7 years.
With what labor?
I meant at the final cycle, at the final 7 year of production, when we want to change the blueberry plant into a new one, that plant could be let to decompose,
Yeah.
and after it's decomposed, could be integrated into the same material, or it could be taken out with labor, plant by plant, just to put it out and be able to recycle the rest.
Yeah, yeah. No, in general, my comment, my first comment is, yeah, I like it. I like the integrated thinking. It's good. It's inspired, I think. So, And this starts looking like aeroponics, doesn't it? Right? If you have a completely closed pot, that basically like that moisture in there is huge. So maybe that's actually kind of what it turns out into if we do the 3D printed. Well, I mean, in fact, that's definitely doable. But then in aeroponics, you're talking about a much more sensitive system, right? So it could be, man, so what if it's kind of a hybrid aeroponic system where there is some aeroponic activity, like the roots can be in a very high moisture environment, and some of it is also just more like the medium. So it's like half aquaponic, or sorry, half hydroponic, half aeroponic. You know, I'm thinking something along those lines. Because aeroponics, yes, great, we can do it, but now that's a different technology that I've never done it, but it's a harder thing because you're talking about moisture, like water vapor. Water vapor is harder to manage than just water, right?
Yes, and one of the reasons we use media such as coco coir, so we're able to do some water retention, and the
Mm-hmm.
plant is able to absorb it from there. But in the case, if we go into this new design or this adapted design, we would have the pot, and below the pot we would have the water chamber that would serve for two functions. One, to be able to maintain and create that humidity that the roots would be absorbing, and two, to be able to flow that water into the single line reservoir and be able to reuse it, of course, treat it and reuse it. So my point of this comment is wouldn't really need the coir or other growing media, since the humidity, which is the important part,
Mm-hmm.
would be present almost full time.
Yeah,
That's expected.
yeah. Now you're getting into actually that's like an R&D project. Are you up for it? Like so, it's like I'm thinking, okay, phase it in. Maybe a part of this you do the aquaponic experiment, and maybe some they're just standard. So what are your thoughts on it? Because I mean, now you're getting into R&D territory.
Correct, but that's what basically I've been doing for the last 3 years with the
Okay.
validation center of blueberry genetics. Now, instead of validating a new variety or genetic, I'm just validating the growing way
Okay.
of
So the
doing.
question is, what's your runway? How much runway do you have?
Wrong way, you mean by what?
How long? So how quickly do you need to get into revenue generation as opposed to you've got money, you got capital to live from or experiment with. You know, then you get
Yeah.
into, yeah.
Oh, well, I don't have a specific amount. Right now, I'm not living of that project. I'm living of the other farm income. This blueberry project is basically on. Right now, I'm validating which genetics give the most
Yeah.
fruit and the most crunchy and big fruit. I will take a decision next year with which one to grow. But if we're talking about this specific project, I would say it's more a cost reduction project instead of wanting to live from that specific project. As of now, the blueberries, when I take a decision, I can grow with conventional growing systems like coco coir, conventional pots, and conventional irrigation systems. This section B, if we can call it like that, it's a cost reduction project. It doesn't have to interfere with a conventional way of growing it.
Okay. Okay. So currently, what would you be thinking about implementing? So say you're ready to plant your blueberries. You know, what?
Next year,
So this would be how many conventional versus how many experimental? Like, what are you looking at?
I
So
would
your
say,
rollout plan? What's your rollout plan?
if possible, it depends on the speed of how we can do it. I would like to do it this same year to be able to have conventional with same variety and this new method with same variety.
So what would be your goal for this year? Like, so by the end of this, like as soon as possible, as soon as we could get this going, with say within a year, how many conventional plants, how many experimental? Maybe do a row. I would say yeah, do like a row, like the 50 row of experimental, and the rest of the
Correct.
normal.
Yeah, or I can do one per variety. I can do normal variety and experimenting variety with the growing chamber that we're talking about. So we have real results with the same situation.
Okay. And for the conventional, how? What are your thoughts on how much you're gonna plant? How many, like hectare or like?
Well, right now it's a hectare, but I'm planning to grow 50 hectares during the next year. But if we're able to reduce the cost, it's going to change the whole perspective.
You're already gearing up for up to, so at least 1 hectare conventional, but up to 50.
When I find the right variety, correct.
Mm-hmm. Okay. And at 50, what kind of time scale are you considering for that?
Within a year, let's say we're talking next November, to be able to, I would say, take the first purchase of the plants. Those takes about 5 months to be ready, and I will be planting on 2027 on the scale of 50 hectares or more.
What are the dependencies for that? That you're gonna definitely do already.
What are the dependencies you mentioned?
Yeah, dependencies. Like, is that so? You're definitely aiming for 50 hectares by 2027. That's your
Yes,
plan. So you've got a budget for that and all that.
I have the conventional budget that I shared before,
Yeah.
so that's really easy to understand. See, it's being replicated in different ways, different parts. Right now, what I'm identifying, it's on my location here in Sonora, in Obregon. I'm I'm putting the different varieties, and I'm waiting about a year and a half to have one cycle of harvest, and then to prune the plants. The plants are gonna pass the summer, all the hot weather, and if they're still doing great, they're gonna be selected to grow into the scale. That's why I'm waiting. It's not the production method. It's basically understanding how the plant is going to react here in my hometown.
What if it doesn't work out? Then you're delayed by a year and a half or something.
If it doesn't work out, you mean in the number of
Uh,
kilograms?
Yeah, yeah. If the plants just don't perform.
Well, that's going to be very sad, but I've been doing this the last 3 years and it already worked out with other varieties. The reason I'm trialing new varieties is because the commercial part of it and the genetics part of it, it makes much more sense for
Okay.
me
Okay.
working with these people instead of the other people I was.
But it could work with what you already know.
Yes,
Okay.
for sure.
Okay. Very cool. Okay. Um, so with the integrated pot system, so we want to basically explore. So the rollout for that is try. So like right now, design out the 50 plant system, the 50 plant to a 55-gallon drum kind of a thing.
Yes, that's the plan. And just going back to your point, right now it's not a validation of market, it's not a validation of genetics. These are worldwide proven genetics.
Mm-hmm.
It's just being 100% sure that in my climate city, they're gonna work as good as the other places that are working. It's just that part, not the market, not the production model. Just making 100% sure before investing any cent into this.
Into that. Otherwise, you're going back to the other ones.
Probably yes, but this market, I mean, this company and these genetics they use, I trust them. I believe in what they do as a family, as a market, and also the genetics. They are worldwide proven.
Okay.
But
Proven.
yes,
Also proven in environments comparable to yours.
very similar. I'm located in Sonora, and they've been proven in Sinaloa, which it's a hot weather, a little more humid. I just want to be really honest when I go to a bank or investor and saying, I proved this, that it worked in my exact location.
Yeah. Yeah. Okay. All right. So what next? So do we want to just start diving into details of, okay, so the integrated pots growing system?
Yes, I see it as a cost strategy, but also as a sustainability strategy. Because if we're talking about recycling water, and right now, at least in these parts of the world, I'm talking Sonora, and I'm also talking Arizona. That would be a next place I would like to grow there.
In Arizona?
Yeah, Yuma, especially because of the weather they have. They have very mild winters. So the opportunity with blueberries that when USA doesn't do production is between October until March, April. So being able to be at Yuma would be able to do mild winters and be able to harvest on those mild winters. That's what I'm positioning first here in Obregón, Sonora. But we have more climates more focused to be able to harvest between February, March, and June would be climates to be able to harvest at least December, January, February. So my goal would be between these two places, be able to get a harvest from December to March, the off season of the United States, to complement my partners who already do production in Peru and they do production in California.
Aha. Okay. Yeah. Um, is that what? So you actually are looking at land in Yuma?
I've been talking, yeah, to some people who manages land and water rights as well. So yes, but that would be step two. First, I want to do it here in Mexico because this is where I currently live and I have land access.
Mm.
And then next step would be doing the June expansion to be able to do more months of production and be
Yeah.
able to supply the gap.
Mm-hmm. Yeah.
I could do it in Mexico if I go more to the center or south. I'm talking about maybe Jalisco, Michoacan, or even Puebla, which is next to Mexico City. But honestly, I want to do both countries and I want to be somewhat close. I mean, Sonora, Arizona are about 5 hour drive. And I also want to make Mexican blues, but United States blues as well. If maybe countries restrictions start to happen, I would love to have a plan B and be able to refocus my business if it's needed.
So if you're saying if the U.S. gets locked down, you still have Mexico? Yeah.
No,
Or
the
the other
other way.
way? Other way?
Yeah, yeah, I'm able to relocate to Yuma and produce into the off season. That's my way of thinking now. But I don't want to be too pessimist. I know we need each other, and Mexico would be step one.
Why is there a risk for Mexico?
Well, with current government, there was a point that they were doing some very high tariff for
Ah.
many types of crops. Blueberries were in risk for about a few weeks. It wasn't that much, but still that could happen at some point of life.
Ah. So Trump's giving you trouble right now, even?
No, not really. With blueberries, it's very open. We need each other. We're on the off season, so we don't affect any American producer.
Ah. Okay.
It's not a president thing. It's about that tariff stuff that if it changes at some point of life, I want to be able to strategize between two countries
Well.
in order to supply each country.
Yeah.
In that case happens, but honestly, I don't see it happen because we're in the off season.
Yeah. Yeah. Okay. That sounds good. Mm-hmm. All right. So let's look at. So what do we do? Let's start strategizing about 3D printing.
Correct. I just want to show you slide number 10. Yeah, I made a
Yep.
drawing.
Okay. I like it.
Just you see
I like it.
the pot inside is the grow media that we're talking about the plastic filament with biochar.
Mm-hmm.
Below that is the I call it drainage concentrator into reloop line. I want that place to be a chamber that it holds some water, but most of it takes the water inside the below line. That would be the reloop line. That reloop line the plan would be adding a pump and moving that water into the line reservoir, the 50-gallon reservoir that each line is going to have, and be able to use all of that as a closed loop system. For me, that would be the integrated growing chamber.
Where I drew the line,
Yes, I'm seeing that.
um, that's the ground level.
Correct.
Tell me the rationale for the underground water reloop line, like the container. So there's underground. You've got some more storage of water. Tell me more about that.
As of now, I just see that there's no rationality about having underground. Maybe it could be into the same, just not underground, and put a structure of piping instead of making excavations for this. That would be more simple.
That's the first thing that comes to my mind. Like if you talk about excavation there, um, you could do an easy trench of a single line, but once you start regular geometry, there's much more digging, you know. So, 60% of water is going into drainage, 6 liters per day. Out of 6 liters per day, you've got 30% going to drainage.
That's what we currently do, yes, as a practice, is to make sure about the variability. Some plants take more, some plants take less, but we do 30% as a buffer.
Oh, drainage, waste into soil, like just waste is getting wasted, right?
Yes, the plant is not taking that.
Um, what happens? It overflows the bottom base. Where's that water go?
To the soil. I don't know exactly, but it
So,
goes to the soil.
so you got the pot, you got the base, so it just overflows out of the base.
It doesn't overflow because we do pulses and we're managing how much water we put. So we
Okay.
put it slowly by pulses. We don't go just putting very much at one moment. We
Yeah.
do single moments. But
So
what?
these, so it goes into the base and probably evaporates.
Okay, that pot is not closed. It has holes
Oh, okay.
below, so it just drains and goes into the soil.
Mm-hmm. And you get these measurements by, let's see, how do you get this measurement? How do you measure the 6 liters? Because you can dose to 6 liters. How do you measure the 30%?
With the drainage tray, what we do, like in the picture, you see the pot. We would put like a pedestal, so the pot is a little higher, and below that pedestal, we would put a tray basically.
Uh-huh, okay, okay.
So if during the day we do 6 liters,
Mm-hmm.
and we see that 30% is below that, that's how we make the reality.
Do you have any pictures of this? How do you catch this water? Did you show any of that? Do you have any real pictures of real life?
Probably yes. I would just need a minute to look into my photos and
Okay. Because if we're going to dive into this, um, yeah, then let's start with exactly what we have. So, study for recycle per line, yep, yep. huh. Okay. So let's design it.
I found the picture. I'm just
Okay.
gonna do here.
Put it into slide 11. Can you
Yes,
do it?
okay.
So in fact, it's 118 plants, about 100 plants row.
With the current capacity of the gallon reservoir, the
Mm-hmm.
50 gallon.
Yep. And you can be that accurate, like you know you can dose it that much, and you can. I mean, yeah, we'll have to figure out those numbers. Yeah, because it's going to change.
You can be accurate, I would say not 100%, since the plant stages they grow a little more each year, and then
Mm-hmm.
we prune them and we adapt back into the next cycle, and also of course the weather structure. I meant how much humidity, how much heat, and also the control environment settings such as the sunshade, such as the ground cover. They do certain reactions, but if we have sensors that have the capacity to absorb all the reality, I
Mm-hmm.
think it's possible to make adaptations.
Uh, to within what percent? Like you got the 1.8 liters, like you would design to like. How, I don't.
Sorry.
You have a feel for when you say the 1.8 liters, like plus minus 5%, 10%.
Yes, that's how I view it. I
What
mean,
what is your
your
uh, uncertainty?
minus and more would be 5%.
Plus minus
But
5%. Yep, just roughly. All right. Okay. Uh, can you put this into? Can you put the picture in here?
I'm doing just that. I'm
Mm-hmm.
gonna do a new slide for that, and then I'll put it there.
Yeah. There's let's see. Hmm. Are you using OSE Linux right now? 2.0? No, you're on your regular computer, right?
No, I'm on Ubuntu, but on this specific computer, I don't have also Linux. I have it on other computer.
Yeah, because there's an issue on that, like with the OSE Linux computer. Yeah, I can't get the video conferencing to work. Yeah,
I, that's an issue. That's why I went back into
yeah,
installing directly the Linux Mint.
yep, yep.
I'm not really sure whether I'm not able to paste it picture.
Um, Control V or edit paste. It's not working. You did it before.
Yep.
Um, okay, that picture. Okay, that.
I I put the link.
Okay, wait. Is that the kind of pot? Is that the real pot you were using, or
You open the link.
yeah, yep. That's
Yes.
that's how you measured it.
Well, yeah, that's on my backyard. It's not the full operation, but I want to show you specifically how we do it. That
Okay,
doesn't even have a drip line.
right. Mm-hmm. All right. I see it. Yeah. Okay. Now, but that's not when you do that in a field. You're not um, the data
Not
you
with
got. It's just from simple systems like that, or you have like a big field system where you tested like each pot.
No, we don't test each pot. We
Yeah, you just,
basically do one
yeah,
percentage, 2%, and we make assumptions.
yep. Okay, I'm just curious. All right, so let's get into the pot design. So, yeah, I mean, let's go at it. Square. So the first question is, what size of print bed we have? There's common printers that have a 1 square foot print bed. We can take an off-the-shelf printer or our own and design for, let's say it's 12 inches. So 12 by 12 by 12 inches, so a cubic foot. That's the current size. Are we on the same page on that?
That can work. You're asking?
Yeah,
Probably yes.
the size that you want to use for real, that's a cubic foot.
How, how many liters would that be?
Uh, 28 liters.
That should be enough for sure. Right now we're using 30 liters, but in conventional way of irrigation. So 20 liters into a growing chamber that has the capacity to maintain water. That should be more than enough.
Okay, so we're good on that. Um, the prototype plants that you have, the trials you're doing, um, those are in a square pots or no? No, which pots are those?
The one you're seeing here in the picture on slide number 10,
Number 10.
that's a circle pot. But if we go into
Yeah.
slide number 16, that's the back, which is a squared back.
And which one are you actually using?
Both.
Both. Okay.
It's a validation. That's what I'm doing both. Honestly, in cost, the back is much more convenient. But if we go into a long-lasting structure, I would say that plastic pot would be better. Why? Because it has the strength to hold the drip lines, and that makes it much easier. The backs is just plastic that when I put the drip lines, it gets like
Squeeze down.
squeezed down, correct?
Mm-hmm.
So my perspective would be using the prototype that we see on slide number 10, like a plastic pot, but be able to adapt it into a conventional 3D printer possibility of
Okay.
sizing.
So if we're going to go with conventional printers, we know there's 12-inch bed printers. And this could be OSE, this could be others. So we're not relying on OSE. If people want to buy it off the shelf, cheap, shipped from China, they can do it if they want to do that. Or they can
Yep.
do lifetime design. So, but let's just make that assumption. So let's say we print with 1 millimeter. I just want to know, the first thing I want to know in this project, okay, how quick can I print one of these pots if they're a single layer, 1 millimeter thick? That's a good assumption because you can definitely print like that, and 1 millimeter filament is common. 1.2 is common. Above that, it gets less common. But let's say even 1.2. We've done, or even 0.8. 0.8, we've done a lot with. We actually liked to do. Let's just say 0.88 millimeters. So millimeter walls. So let's calculation. What's the what's the amount of filament? How many grams of filament do we need for that? So let's say TPU. Let's just stick to TPU for rubber. So it's because if we could do TPU like also for fittings and all kinds of things, that would be interesting. But let's just do that, and they're comparable weights as far as that. So the question is, let's ask chat, for example, if you got a square box that's going to have 5 sides, so it's going to be 5 square feet. So I'm going to ask chat, how many grams of TPU are in 5 square feet of a 3D print that is 0.8 millimeter thick? Let's see what we get. Because then we're designing for because the first thing I want to know is, okay, is this practical to print this, or is this crazy? Because we already said that, hey, the material we can get at that low cost. Lowest I found was 14 cents per pound. Let's put that in a doc. So let's say TPU source 14 cents per pound for a square container. 0.8 millimeter walls for a square container. Now this is just to get our feet wet, because then we can make it round. Round is easier to print because you can print this. It's easier. You don't have the jagged edges, right?
Yes.
So, but it wants to be solid. It wants to have a lid. Wants to have a base. Let's see. But let's start with just the kind of mass we're talking about. So it's telling me volume. No, it's not 5 square feet. It's no. But 5 square feet, 0.8 millimeter tall. It'd give me a full box. 5 square feet. Oh, that gets actually quite heavy. So just a reality check here. I'm reading 5 square feet of TPU at 0.8 millimeter thickness weighs 446 grams. Holy cow, that's a lot.
But that's not a bad thing, because if we go into the harvesting, we want to do mechanical harvesting. We talk about the air harvester.
Mm-hmm.
So if it's heavy, that's gonna help.
Mm-hmm.
Since we're shaking with us physical movement, but we're gonna use air to move both of the branches into throwing out the fruit when it's mature enough. So heavy, I think it's good.
Or you can design it such that you can weigh it down with water, because you leave enough reservoir at the bottom. That's another option. You see what I'm saying? Like if you have enough of a container at the very bottom, that could also do it. But
Yes.
okay, but 446 grams. Wow. Container weighs 400. So let's say 450 grams. I'm gonna put a link to that so you can take a look at it. Have you been using like any AIs like ChatGPT or stuff? A little bit.
Yes. Very much,
Very
not
much,
little.
yeah.
Yes.
Mm-hmm.
Now I'm using more Gemini from Google, but I believe that most of them are really good now.
Yeah. For the questions I ask, it's Gemini. Like, I don't like it. I like,
You would go ChatGPT or Claude?
yeah, like a lot of times Gemini is much, maybe a bias for more optimistic answers in Chat GPT. But like when I what give you an example. Whenever I ask Gemini, it's like it gives me it depends, and it's doesn't give me specifics. Whereas for Chat, it gives me like a specific case and numbers. Like I don't want to hear it depends. Show me what your assumptions are and give me a number. you
It,
know.
it helps a lot. I was thinking about moving into another chat because the answers, honestly, they try to be very soft. So I agree with you.
Yeah. Okay. So I copied the link so I can. So if you click on it, so just as an example here, can you click on that link and does it actually get you the same thing? So it gets you my chat.
Yes.
Okay. So you got that. Wow. Okay. So print rate. What do we got for print rates? So for that we go into, for example, if we use super volcano nozzles, and I still go back to super volcano by E3D. these particular nozzles, super volcano nozzles. So I'm going to go, for example, to the wiki. I'm going to look at super volcano.
On OCWiki?
Yeah, OSC wiki, super volcano nozzle. And let's say it's 10 pounds of material per day. That's what I have there. 10 pounds of material per day per 24 hours. So we can print 10 pots like that with a super volcano nozzle per day. That's great because this thing is automated, right? So we're just printing 24/7.
And you mentioned 24 pots, 1 pot per hour.
One pot every 2 hours. So
12 pots per day.
about 10. If it's 10 pounds per day, 454 grams is about a pound. In fact, it's
Yes.
just about a pound. So 10 pounds, 10 pots. Pound a pot. So these are much heavier now than what you're used to, probably, right? I mean, a
Yes.
pot like that doesn't weigh a pound, right? Yeah. So which is good for recycling down the road. We got a lot of mass, right? Mm-hmm.
Yes. You mentioned before about making with water more heavy the pot, but
Mm-hmm.
if we think about biochar and plastic filament, where that water is going to hold, since we don't have a growing media such as coco coir to be able to
So you,
hold it.
so so here's that pot. You can go taller. We'll make OSC printers that go to however much you like, a few feet, or 4 feet, 6 feet, 8 feet. Do a chamber at the bottom which just carries water. And now that you have to work out the hydraulics, what happens at the bottom. But say this is the water chamber. I'm doing the same thing you are. You got your pot drainage, but if I do so water reservoir, you got water reservoir there. You can make that whatever you like. You can do that. You're not using more water. That's one-time input. As long as you don't get bacteria in there growing, as long as you got flow, it doesn't matter how big the water reservoir. In fact, all your pots could be reservoirs. You can get rid of that 55-gallon drum. There you go.
Yes.
So you can do it different ways. So you can you can do that. Let's do a couple of versions here where you got a lot of water at the bottom. Oh no. Um, you can have a big reservoir like that. Um, we're not limited to vertical. Vertical is easy to print, so we're okay. We're okay with that. 10 pounds. Um, I'll put a link to that. So that's doable. I mean, so how long does it take you want a hectare? How many days per hectare? 5,000. That's a year of printing. But that's one printer. So you put,
But one printer.
yeah, so you put a little cluster and you've got a month and you've got a hectare. So you invest yourself in a cluster of 12, or, well, I was gonna say multi-headed printer, but no, you're taking up the whole bed with that print. Um, yeah, I think a cluster. So let's talk about equals. That's equals 10 pots per day. But then hectare equals about 5,000 or so, right?
5,000. Yes.
About 5,000. So you're talking about 500 days.
With a single printer.
Yeah. Print cluster of 12. That's a realistic thing. 12 printers. You've got what? 40 days? About 40 days.
41 days.
Yeah. Yeah, it's doable. And now that's what's your yeah. What's the revenue per hectare? No, okay, give me the bottom line for per plant. Now, it, after all your costs, what's your
Cost of,
net after you
in
pay?
Mexico, cost of production would be at max. I'm talking about FOB, that means finished product ready to export. It's harvested, it's pre-cooled, it's packed, it's palletized, and it's in a cold room. That would be per kilogram. I would say at max 3 USD. And it shouldn't be that much. It's less, but for this example, we're going to do that.
Three
And
dollars per kilogram.
yeah, I would say 250, being honest.
Is that net or that's your sale price?
That's the total cost of having the finished product in the cold storage ready to be picked by the marketer. With packed, with selection, with cooling, with harvested, with production, with all of that. That's finished product. And it's, I would say, much less than 3 USD. But just for this reference, let's keep it that way. And prices on the months that we harvest, which is the off season of the United States, I would say it's at least 750 USD.
Hmm.
That's on good prices, and I would say not so good would be about 4 USD, but that hasn't happened in 5 years. And
Average is what's average? Like five, six?
let's do five, being very conservative.
Yeah.
And here I'm talking about the premium blueberries, which is the main reason I'm validating different genetics. Conventional blueberry, it's small, it's sour, it's not crunchy. These ones are crunchy, big, and sweet. That's the difference.
That's premium. How many? Let's see. And you're only gonna do premium, right?
I'm only doing premium, and the
Okay.
plant has to give me at least 80% of the full volume to be at premium. Premium means 19 millimeters. Brix, which is the sugar and acid ratio, should be at least 11. And crunchy, you measure it with a tool, but I can't remember that part. But I will put it here. It's the
Okay.
pressure. Pressure is basically what defines how crunchy it is, but it has a measure that I will put on the document.
Aha. Okay. Put in your crunch meter score here. That's awesome.
Correct. Yes.
19 millimeters. Wow. Up to how much? How many?
Well, some varieties go on average to 24 millimeters.
Wow. Man, that's
They're
that's
delicious, honestly.
yeah, yeah, yeah. Pretty soon they're gonna be big like watermelons.
Probably, but I don't think that's the perspective of a blueberry. They should be like a snack, easy
Yeah.
to use.
Okay. At least golf ball sized. All right. That would be good.
Some, yes.
Oh man, that would be
Yeah.
good. All right. So we're gonna print some pots. We're gonna get printers, and we're gonna do recycled filament. So that's technicalities. Okay. The big thing to test out now is, man, this stuff about the carbon, the biochar in there. So that's research from Joshua Pierce. We can look into what he's got. I can follow up on that. Uh, let's see. Let's see if anything comes up online. Um, biochar 3D printing.
I did some research, couldn't find anything specific on hydroponics.
Yeah, he does have. So let's see. Where's that link? Let's see if we got it. Um, oh yeah, ground nut shells. Oh yeah. Okay, here's. Oh, that's in some. Yeah, it does come up. If you look at this. Okay, so let's put that link in the So now biochar 3D printing. So 3D printing is shredder, filament maker, and okay, so we can get into those. Um, biochar filled. So I'll put a link here so you can start looking into that. Some stuff came up for me there. So how do we do this? So from what we know right here, let's do a little diagram of. So let's start labeling. So the top. I'm gonna do a. We want to have something like at least some closure at the top so it's solid. So it's got a stiff upper lip if it's a square, right? So
Yes, we need that drip line to be able to be fixed.
yeah, so we'll fatten up this part. Let's make it more prominent. So it's got this fat lip on one side and the other. I mean, the first thing that comes to mind on a biochar is, well, let's read those papers. But what's biochar for? It gives airspace, additional airspace, so that you've got microbial growth. Yeah. So if we're going to fill this up, yeah, I mean, we can start by thinking, okay, we're going to just fill that with spaghetti. You know, spaghetti, like a failed 3D print, right?
Yes, I
Okay.
did some research.
Okay.
Yes.
So print spaghetti, and that thing's got, so quite a bit of volume, but it's largely air. Now I'm thinking if you print, I mean, if you think about it, that's like literally printing a sponge almost. And if it's got more airspace or more water catchment ability because of the biochar, and I've read nothing about the biochar, then we could be in business. But as prototype one, we can say, okay, spaghetti, biochar filled spaghetti print. Spaghetti print. Now we need that filament, right? So how do we do that? We need to get some biochar. We could make it. We could buy it, and then we can start printing it. But the first thing would be just spaghetti by itself. How about that?
How would that
If
impact in the water retaining part? I mean, we do the irrigation and we do it slowly. I get that. But how does the root is going to be able to absorb that water? That water comes with a certain pH, with certain nutrients. And if we just do the spaghetti part, how would we achieve that retention of water so the root is able to absorb it?
yeah, well, so let's say there's a lot of different strategies. We can go through a bunch of different scenarios. So we can go with one scenario where what if you've got the conduits at the bottom. Okay, so the pipe goes through the bottom. It connects, it drains into each pod, and it's a connecting pipe. But what if you're filling, like, you just make the water level go up and like ebb and flow? What about that? Ebb and
That's
flow.
that's a possibility.
Um,
Yes.
but that's a hard deal because then you need like a few gallons per pot. That would be difficult. So you probably want to dribble from the top by gravity. Now and before we get into any of this, what were you able to find out on, say, did you look into this, like when you start looking at your pot design, did you start looking into Chat GPT or anything, or?
I started asking about more specifically on the growing media, what's the function of it? and then understanding that the function was basically retaining water and be able to create air spaces so the root can develop from there. That's what I start imagining about different solutions. So plastic filaments with biochar, what I understood is that maybe the biochar and the plastic design, you mentioned spaghetti, could be a way to retain the water, not to hold it, but at least to make it slowly go
Yeah,
down. And that could be an opportunity, each pulse of water that we get
yeah.
to to the plant to absorb it through the roots. Since it's not gonna be a
Wow.
water that's gonna hold the water, maybe that design of spaghetti,
Hmm.
it's gonna make a slow cascade that is gonna be able to give the root the opportunity to absorb the water nutrients. That was what I got with the research.
Yeah, and any indication on how much water biochar holds? Does it also have that function, or no? It doesn't really hold the water.
I don't have that specific data point.
Let me see. Does biochar hold water? But this is pretty exciting. Imagine we do waste 3D printing and biochar, which is widely accessible. Um, that would be exciting because then you can talk about growing stuff anywhere, like at low cost. Um, Water holding capacity. Um, like a permanent sponge, yes, can hold 2 to 6 times its own weight in water. That's good news. This is ChatGPT.
Well, right, biochar is used on the soil, so you have more retention of water. So of
Yeah.
course it can hold water.
But fresh biochar is often hydrophobic, so it needs to be wetted to become fully hydrophilic. It says like, or soaked with compost tea nutrient solution, and then becomes hydrophilic. Yeah,
That
once wetted or aged, becomes excellent at retaining both water and nutrients.
and that's
Yeah.
day to day on irrigation. At least with pulses, we do structure formulations that deliver just that.
Into 3D printing filament. So tell me about, um, I'm just asking here. So it's got increased once you, yeah, no, I mean, we got to study this. Let's read some papers here. So
Okay.
let's share this. Yeah, it's been done. Like, it's sending me to different sources. Like, for example, studies in 2018 through 2023, so recent stuff, have found increased stiffness, reduced elongation at break, improved dimensional stability, improved thermal stability, light weighting. So it could make the filament even more lightweight. That would be nice. Um, Wood-filled PLA already has. Research in Europe have made PLA biochar composites with 5 to 30% loading, usable print quality and stiffer parts. Interesting. So up to 30%. Huh. So then 5 to 30% of biochar in that filament. So the case, yeah, I mean, the first thing we want to look at is, well, there's feasibility, like cost feasibility, like what is the cost, since we're developing this on here, so let's look at
About
cost.
cost feasibility, we saw that on a 35-liter coco coir, we spend at least 2.8 US dollars per pot. So that could be the base.
80, so we're competing with 80 cents per pot.
with 2.8 USD per pot. That's just in the coco coir.
Okay, coco coir only by itself is $2.8.
Correct. The cost of the material.
Oh, that high. That was. I thought you said it was something lower than that, like a dollar.
No,
No, two point
that's
eight.
yes, and that's the cost of the material. I didn't put the labor to take the coco coir, to separate it, and then to put it inside each pot.
Yeah, that's it's not particularly cheap. Like, how many kilos you've got? What, 2 kilos?
No, 35 kilos. Oh no,
No, no,
35 liters.
35. Okay, so let's say how much does
It's
35 liters of
it's all
cocoa
by
make?
volume on the industry. They sell you like 1,000 liter or two
Mm-hmm.
thousand liter packs, not by kilos, but we can
Okay.
measure by kilos for sure.
Yeah, weighs about 2.6 kilos for that
Okay,
30, it says 35 liters. So yeah, I was close to a few kilos, couple of kilos. Wow, that's over $1 a kilo. That's expensive.
very expensive.
Wow. Huh.
If we're able to validate this, you mentioned how much could I do with this new system and with conventional system. If we do this system, we could basically do by 10 with the same amount of money, since we're doing less cost on irrigation, less cost on coir, less cost on water, since it's going to be a water reloop. So for me, it's top priority being able to figure this out than just scaling with conventional systems. Since they work, it's a business for sure, but it's a lot of capital to be asked
Yeah.
to work with.
Okay. Wow. Then okay, then that makes it pretty easy. That's expensive. Okay. Now we can compare. Say we did spaghetti and it's got a lot of air. So the advantage over coco coir is that you have airspace. Coco coir does not. It's like coco coir. Yes, it has its own internal airspace. I don't know, maybe like 50%. What would you estimate? Like 50%? What's the airspace in coco coir? This percent airspace in coco coir. What would you? I guess 50. What's your guess?
Okay.
No, it says only 10 to 30%. Wow. So it's mostly. So you're paying mostly for that biomass. Okay, only 10 to 30%.
And you got that data
This
with the
is
term airfield porosity.
yeah, yeah. The
Say
airspace.
I'm a
Mm-hmm.
Gemini and 25 to 35%.
Yep, yep. Um, yep, yep. So let's put that in there. So we got. So go into that doc and put in some data points because this is all important information. So slide number 12. Coco coir is 10 to 30%. Let's hyperlink to sources air space. So that's that Gemini link. Okay, I did it. Cool. So now the next question is the cost of um, how to think about it. If imagine we had the same amount of volume of biochar, it was 1-to-1 biochar, and I know we're not because we can design airspace into it with spaghetti, right? So we know we can do better. But let's get a baseline for let's say I'm making an assumption biochar is comparable in weight to coco coir, which we can verify. Can you get the density of coco coir versus biochar? Can you get me a?
Yes, I'll do that
Mm-hmm.
right now.
Yep.
coco coir, it's measured by grams per centimeter.
Hmm.
It's 0.03 to 0.10. Biochar
Okay,
is,
type it in. Go ahead, type it in. Put it
yeah,
into the doc.
you're right.
So 4E. I'm gonna get the density of. I'm gonna try to get density of spaghetti, of 3D printed spaghetti. Can you put like a, so 4E?
Yeah,
Yeah, yeah, yeah.
I
Okay,
will organize it.
okay.
It's just for typing.
Mm-hmm. I mean, a simple question is for spaghetti. I'm gonna ask chat. Hey, can we do that for hydroponics? Oh yeah, I think we got the answer. Yeah, I mean, I'm asking it about spaghetti, and it's saying yeah, mix biochar cocoa fiber with it. So we probably can let's print spaghetti and half spaghetti, half cocoa coir. There's your answer, and you get 50% cost reduction. I would say.
Big. That's big. Good
So
stuff.
so we already saved in the last 1 hour. We saved $7,500 per hectare.
Yes.
That's got to work. I don't see why that's not going to work. You're adding porosity through spaghetti, and then and
It's a
spaghetti
fun.
can that's like the art of spaghetti. Now we turn that into a research product. All kinds of properties, like what's the speed of print, like how do you do it, all the parameters. That would be the next steps. But it's I mean, this is like R&D at a university kind of a thing. Um, so we're gonna have to start a university at next to your farm. Yeah. Regarding that, yeah. Did you have any new thoughts regarding getting talent in to a place like Mexico? Because restrictions for immigration are not there, right? And
No,
therefore, um, but what are your thoughts on, okay, if we're teaching people there, are we actually doing the same business model with housing? Like, are we going to be building homes in that market?
yes, for sure. I mean, the cost that can be achieved with your designs, the open source ones, they work very well here in Mexico. I mean, the housing costs that we have here, they tend to be not similar to the US, but not that different. I mean, a little bit lower. So there's
So,
a huge need here.
give me some numbers, like 1,375 square, 138 square meter, 2 bedroom, or 3 bedroom, 2 bath. That's what we do.
You mentioned how many meters?
Like 130.
130 square meters. Well,
But okay, so yeah, man.
no, no, that's a small house, correct?
Yeah, it's not big, not big, not too big.
I would say a 300-meter house already built in the industry, like in a private lot. That
300. That's
has,
pretty big. That's it's big.
uh, Well, yeah, I'm talking about the whole terrain. You're right. Let's say that in that terrain, with the house on the 100 that you mentioned, you can find 4 million pesos currently in a zone that it's privileged. I mean, privileged in small cities, correct? Not in big cities. That would be
Yeah, that
200.
works. Yeah, we
Yes,
could do. Yeah.
but we're talking that that didn't cost like that a few years ago. Like since COVID, all the materials
Oh
just
man.
went crazy, and it was before like half of it.
So is the 4 million? Is that for like the smaller or the standard like three smaller?
Like the standard that you mentioned. I meant that 300 space area, but it doesn't mean that it's all house. It means that it's area for a garden, area for a garage. So
Ah,
your model it would be
similar to that. Okay.
similar to that.
Huh. Interesting. So yeah, I'm thinking about it. I mean, that's a real possibility. The next thing is for us is to determine whether after we get the pick, the package correctly presented, are people signing up? Is immigration really a big issue because most people want to come from abroad? We'll see. If that is a showstopper, there's Mexico.
Yes,
Yeah.
I'll do some research for the next call, but honestly, we don't have now regulations, neither the government perspective to be wanting to stop students, creators, builders of adding value to Mexico. Of course, we don't want people that is not adding value, but it's not the main focus of the government, as I understand. I'm not an expert into this, but I see people from all around the world come to work in industries here.
Yeah. Very nice. Mm-hmm.
So
Okay.
yes, it's a possibility. Economics in housing, they match about what you mentioned, meters by price in the current market.
Hmm.
And of
It's
course,
interesting. Yeah. Yeah. Okay. Yeah. Yeah. We'll keep considering that. Okay. So so biochar is lighter than coco coir. Aha.
what exactly, just going back a little bit about that topic, what answers can I get to you next week about making Mexico the makerspace for this?
Cost of housing. What? What? If we build like we build here, look at Zillow again. You've seen the
Yes.
1005 Sycamore Drive in Zillow.
Yeah.
Okay. Give me a comparable house to. I know it would look different. Probably one. We're migrating more to one story and stuff. Give me some realistic numbers because if that business model completely works there, oh wow, that would be. I was assuming that the prices are going to be way lower and it's a different situation. Yeah.
It's a sad situation how expensive it based on what people earn here in Mexico.
Uh,
Wages are much
no,
lower.
that's right.
Housing crisis is awful.
Wow. Hmm.
I'll do for you.
Yeah.
Some of my friends, they basically are builders of houses,
Mm-hmm.
housing structures. They do like serial building of the
Yeah.
houses in certain private scenarios. So yes, I have access to current cost of houses, current cost of materials, and I could develop to you a certain idea what's the ecosystem, at least in the north part of Mexico.
Yeah, and tell me also, is it also going to be a lot of stonework, clay and tile, as opposed to wood?
You want the cost of
No,
stone,
I want to know is are they building mostly with stone or with wood?
concrete.
And what about wood? How much wood do they use?
It's not very common in Mexico on conventional housing to be using wood such as United States.
Yeah, so
The
we would have
panels,
to rework our model to be more with local tastes. How would we do that?
with price, honestly. what I mean by this, if you can give a livable house at a more economic price and it's very safe and nice to live, I don't think people's gonna be thinking about wood or concrete. They're gonna be thinking about the opportunity to have a safe home.
So you're saying we could do wood?
If it's gonna make economic sense and it's secure, yes, that's a product that can fit.
And how do we do the R&D for that? That means we're in our program we develop that know-how with our students.
Yes.
Okay.
I mean, the reason we do concrete here is because yes, the cost, but if you want to find an architect, you want to find a builder, they're not going to tell you about wood since this is not their expertise.
I see. I see. Now, the only other thing would be termites. You have bad termite problems there? In a desert?
Not
Not in a desert, that's in a jungle.
correct. I mean, we don't have that much humidity, so maybe in the jungle or in the south of Mexico, but if we start here in Sonora,
Yeah,
we're talking about desert like Arizona. So they have issues in Arizona? I don't think so.
no, probably not as much. Yeah, definitely not. Okay,
Okay, I'll do that.
yeah, yeah,
Material cost and comparable houses like the one in
yeah,
Silo, just to get a clear structure of how it's made.
yeah, yeah. Price and build technique.
Correct.
Yeah,
Okay.
yeah, excellent, excellent. So it's back to the 3D printing stuff with we're seeing that biochar is actually much lighter, or like half the weight, let's say, from your numbers. And um, okay, so I'm gonna put that a link to that biochar filled spaghetti print. Take a look at that chat. It's a thing. It's a thing. Probably not. I mean, not developed. I mean, it's not gonna be standardized. Nobody's doing. So this is like, I mean, you can call it cutting edge because I mean I haven't heard anybody do that in practice, but it's certainly doable, right? And Joshua Pierce, there's R&D papers on that. Now to productize it, yeah, that's a perfect thing. It's one of those low-hanging fruits because 3D printing technology is available. We can get our hands on extruders that you can mix the biochar into that. So yeah, let's say maybe for next week. Let's look. Do you have some time to look into that? So we're doing the pots. We just got into the growing medium. We can talk about the conduits and the top closure, but we're kind of going towards like a hybrid aero hydroponic thing because as soon as you get the spaghetti in there, that's we can in principle get the airspace and reduce material costs. Do you want to do any? Do you want to? Can you do like maybe a little legwork, play with chat, and do something like make some assumptions for if we've got 3D printed plastic. So now we already found we're at about a pound just for the structure. Okay, we're there.
Yes.
Now, how much is, make an assumption you've got that cubic foot, your 32 liters of spaghetti. So let's start getting some numbers. Okay, how much does that weigh? You know, you got to start exploring it. How much does the spaghetti weigh? What, question number 2. I'll give you a few questions that are relevant.
Yes.
What kind of airspace in 3D printed spaghetti is sufficient or adequate to function as a growing medium? You can look at the chat I already put in there. Keep building on that. You know, like when you share a chat, it takes a snapshot. So if I snapshotted it at the beginning, which is there, it's a thing. You can, after you add to it, you can share again. It has the share thing, and it will give
Yes.
you all the updated stuff.
Okay.
So what airspace is desirable for stuff that works like a growing medium? Okay.
Yes.
And then we can say, what's the cost of that? And start getting an idea of composites. So composites are mixtures or solutions. So you were talking about if we throw biochar in there, let's say you've got that airspace. How much would it cost with biochar? How much would it cost? Like, what's a reasonable fraction? So we're exploring all these kinds of options, but what's a reasonable fraction? Like, say you do 50-50 spaghetti and biochar, as we just said already. What's the cost? So you have to have weight, and you have to have off-the-shelf cost. Like, for example, for biochar, you can say commodity cost. We already know printing filament. We said $50 to $100 per ton bale if you do waste plastic, or 14 cents per pound. So we've got some numbers on that. Let's get numbers. You already gave me the coco coir. We got that. It's expensive.
Yes.
Now look at biochar. Yeah, get a cost on biochar off the shelf, because we can make it. You can burn wood and you get biochar. It's not that
Yeah,
hard.
we have a lot of wood with the pecan and citrus operation. We have to prune every year, and we don't have a model to put all that wood. So that's a perfect transition.
And I think that's what they're doing. Like with Joshua Pierce, they were talking about some shells from some nut waste shells from a nut crop. Yeah, so that's perfect. So you're talking about ecologies there. And then what else do we need to know? That's it. Let's get some like a cost. So cost, new cost, and we kind of already said, oh, we'll fill half with spaghetti, half with coco coir just by volume. Because then you have to start thinking like the structure of that spaghetti, and then the structure of coco coir. How would that mix? Like, we have to then do some experiments and see, oh, if I just take some failed 3D print and put a bunch of experiment number 1 and put a bunch of coco coir in there, how much of it gets in there? Does it actually fall down into it? Do you have to like shake it around to mix it? And does it stay mixed like that? Does it tend to like settle? I don't know. I've never done any of this. But we can start asking about that. So maybe let's get some of these base costs, and it looks positive. I mean, already already looks positive. Where's my video? Not sure where my video.
I agree. Of course, I'm going to do this. I'm going to start just by understanding first the real function of what needs to happen on the root. If it has different colors, I mean, it has cocoa, it has perlite. There are different ways of managing the conventional blueberry. But I would start first on what's the real function that needs to happen. And of course, I'm going to start asking the questions about the weight, the porosity, mixing one-on-one. I mean, one biochar, one plastic filament, then mixing one coco coir to one plastic filament, just to be understanding how is the reaction of different materials. Then I'm just repeating what I understood, if I understood correctly. Then I'm gonna do the cost structure of the shelf, then on the recycling part. And I think that's the main assumptions I need to be answering. I'm gonna support it with the chat, and I'm also gonna have some support of my current plant advisor. He's a guy from Chile, which has 30 years of experience just doing hydroponics, specifically blueberries. So I think he can play an important part of saying this how it works, and then I can find how else to make it work with these current ideas.
Yeah. Did you say agroponics?
Hydroponics?
Hydroponics. Yeah. There you go.
Yes.
Yeah. And then we can definitely look into, so after we solve the materials, then we might just, we're just doing some conceptual work right now, but let's migrate this conceptual to, okay, let's just execute on some of these things. So like, probably like machines for making filament, might turn into, if we find that biochar is a really attractive thing, then we need to invest in biochar making equipment. But that could be simple or as complex or as simple as you want, depending on how much labor, of course, you want to put into that. If you want to do an automated system, one thing I did think about for biochar, because we did a power cube that ran on biochar, and it's like, that's interesting. It does work. So if you pelletize, the pelletizer is one of the Global Village construction set tools.
Yes.
Imagine a pellet stove with an auger where you rotate and get it out of the fire before it burns completely. Okay? That's called a biochar producer. You burn it partially, and then you starve it of oxygen so it stops the burn. But we can talk about a simple thing. Like, I actually thought about it for heating, for space heating, and the product is actually biochar. So that would be, maybe we get into that. It sounds, I don't know if that makes sense right now. It depends on whether biochar is already a good, well, if biochar is a really good option here or not. And do we have to make it ourselves? Can we just start, well, just get some off the shelf? If it's cheaper than coco coir, then we could possibly buy it and forget about that. And phase two would be we actually make it. Yeah.
Yes. Cost is gonna give us the guidance where to focus on,
Yep.
for sure. I have a few questions, not of this. It's
Sure.
about technology,
Yep.
since I'm
Sure.
learning this open source, and I would say, some computers. I want to focus on single computer systems. You would go on Linux Mint as a single system, or do you have different operating systems? Talking about
I have,
computer.
yeah, I have Linux Mint and I just use that. It's good. Um, I don't discriminate a lot between Linux Mint seems to be pretty good. Hmm.
And on the hardware, what specifics do you use?
Oh, I- I've got Aorus M B450. I just got a motherboard. It's I don't even have a box for it. I just have a graphics card on it. It's just a motherboard. Um, but I don't know. I don't know. I haven't looked into that. There's let me send you the link for what we have because I documented that. So, but this was, I mean, this was like, this is what I use right now. So that's Ryzen 3400G processor. That's what I do. I did this. Um, that's exactly
Okay.
what I did. But that was a few years ago. Now they've changed, so you got to update it probably. And I'm actually, um, to me, it's like brand new. It's like 7 years, but no, it's already starting to slow down. When I do a lot of docs and video, it just starts to slow down already. It's like, man, it used to be super fast before. Now, for whatever reason, the software got more complex or whatever. Yeah.
And last question about phones. So I've been using, I would say, Mac products most of my life, the Mac OS laptops and the iPhone. I have done Android as well. I did it for 2 years, which was good. But going back into putting my life into open source, what would be your perfect setup? Because I don't want to be changing into different systems my whole life.
Yeah. No, I would go with Android. I actually use Graphene OS,
I read
but,
about that.
but man, some stuff just doesn't work. It's a pain. Like right now, if you do like all this social media, like right now I'm in public, I'm getting out into the public. Some stuff just wasn't working. Sometimes there's bugs. It's still got some bugs. Like I forget what specific one, but I would. I mean, it's so secure that like you can't talk to people sometimes. You know, like
That's
it's
not the
not.
goal.
Hmm? No, it's not
That,
that.
that,
So I
not
would go. I wouldn't do graphene. Like I haven't been happy with it. Like some apps, like for example, even like the photo app sometimes just doesn't work. Um, it's pretty good typically, but I would go with just some stock like Android. Yeah, just start with Android. I haven't looked into the details of that, but I think the thing to learn is to be able to switch between, like, get to the point where you understand the system enough that you're not troubled by using one or the other. Like, for example, I used to pay more attention. Oh, like, what are we going to do for OSE is like, because first it was actually Ubuntu, and then we went to Linux Mint, but Ubuntu got a little corporate and stuff, uh, so we didn't like it. There's a, if you want to go like the hardcore route, that's Debian. That's free, like GNU, kind of. That's like Richard Stallman stuff. But I think that's for long term. It's got a definitely a hardcore open source radical community. Maybe maybe some of those people are so far radical that maybe too radical. Um, but definitely like Libre, like all that stuff, they do it. They're not gonna sell out. Like so, Debian is not gonna sell out. Like Mint, I have pretty good confidence. But what you do is look at the long-term sustainability when you just search it. Like for example, we've used PHP list for email list. It turns out it's fully open source, but it turns out it's actually high risk for discontinuity because it's I think it's because it's a small team and it hasn't been updated for a long time. It's just like a legacy thing. So there's some other things, but because these things change, I think you have to be a little flexible and
Yes.
and really gain a more comprehensive skill set. So, for example, say like Linux Mint just went out tomorrow, I could just go on chat and say, okay, this is nonsense. What's a stable, long-term operating system? And then you put in all your values. Like your values are, it's not going to sell out or it's going to be long-term supported. Like all that kind of stuff. And just ask those questions to get the best results. Because right now with AI, like you can get to answers pretty fast.
Yes.
So man, like instead of worrying about if I've got the best thing, my approach is okay. I'll do the best I can right now. Do of course do a little bit of research, but then it's like be flexible to switch at any time because things can change at any time. You know,
Makes sense.
that's kind of my approach these days. So yeah,
Okay, I appreciate it. I mean, my goal is not much privacy. I mean, I'm doing everything open source. It would be more cost oriented. For me, my big desire
yeah,
would be to go to rural America, like rural Mexico, and give them a device that is really cheap and they have total ability to develop themselves with this device without having to be paying with apps
yeah,
or systems.
yeah,
That's my goal. I don't care about privacy.
yeah,
Just don't buy with the ads. That's the only solution. I don't need that much privacy thing.
yeah,
Google it, it's okay. It's
yeah.
just the devices thing and the software thing. As much as it's good and free, for me, it's better. That's why I'm asking.
Yeah, I mean, but absolutely use everything that's as radically open source and not selling out as possible. Like FreeCAD, I still believe FreeCAD is going to take over the world of CAD. Why? Because it's improving and it's so expandable. You can program it. Like, for example, right now, like after, for example, we develop the open source blueberries or whatever open source irrigation, you can create a workbench in it pretty easily. You can have like drag and drop. Here's the container part, or maybe a parametrically defined growing container that you can make any shape according to a design that we already worked out. I mean, you can do all of that. It's completely customizable, which is the most beautiful thing. It's OSE Workbenches platform. Have you seen that on the wiki?
No, not
Okay, yeah.
yet.
I mean, we already have documented how you can create new workbenches. You know how, for example, you have tech draw workbench, you have part design workbench, exploded part animations workbench. You can
Yes,
create one of those things. And we have done a little bit of that, like for example, 3D printer design workbench, where we drag and drop some of the parts that we have in the printer already. So it's like automated design. That you can do in FreeCAD, and you can't do that in anything else. You know, I think it's going to be better over time.
mm,
Is my opinion because it's open source, but people haven't caught on to that. But
sounds
anyways,
great.
yeah. So always go for like whatever the new software for list servers are. Okay, it's going to have to be open source. Like we're going to have full control of it. It's all the distributive economic aspects. Just pay attention to that. And sometimes maybe even like I don't know, there might be some proprietary businesses that are doing like really good work
Yes,
I don't know. I don't really. I don't know. Like Google. Well,
agree.
Google does a lot of good. I mean, Google has created a lot of value, right? So,
Yes, very
um,
much. I
yeah,
like those guys very much, but I like more free stuff that I can distribute to
yeah,
people who don't have the resources.
yeah. I mean, that's the game changer because then anybody can do it. You don't have to have money, big money for it. Just like with the housing, if we publish the open source stamped engineering designs as reference designs, right? Then the next person can download them. Like for example, for the PV system, I'm required to get an engineering, like electrical engineering for the photovoltaic system in some jurisdictions. Well, if we publish that, the next person can download that and just show it to their department, right? So that kind of stuff makes sense. So yeah, open everything is that's the future. Absolutely, it's gonna happen soon, and we're doing it. So yeah.
Thank you very much. I will work with this information and you let me know when we can do next call.
Yeah, let's try for the Tuesday. I'll get you an invite right now. I got to get you the login, the Google Drive stuff, so you have a open source ecology account. So
Yes,
therefore, you have the you have the Google Drive access, so the documents can live there in case you disappear. Not, um, and then you can also if you're outreaching to people under OSE, you can also use that email for other things too. Yeah. Okay.
appreciate it.
Mm-hmm.
We'll talk soon then. Thank you very much, Marcin.
Thank you. We'll keep it going. This is exciting, so I like it.
You do
Mm-hmm.
very much.
Okay.
Bye.
Take care. Bye bye.